The unidimensional variables are very useful when programming, and it's because one normal variable, for instance this myvar instance, is just one place in the memory for storing one integer variable. Each value can change. Any value that fits inside the int variable will fit for this reserved space. However, sometimes we want with one same name, with one same pointer, the same variable, to make reference not for just one integer, but to a set of integers. So we have to think, I need then space enough for reference all of them. And for this purpose, we have to use the unidimensional variables, the arrays or the vectors, according to the names we are going to adopt. And every array has one size related to. This size indicates how many spaces are going to be allocated in memory for this type. So in this example, we have 15 spaces reserved for int variables. So from the position here 0 to 14, we can reference integer variables. We cannot change the type of that for bigger types. For instance, as instance the long type, because the more space will be necessary. Okay, so here is one way for declaring one array with 15 elements that will be non-initialized, all assuming the default value of its type. In this case, the default type value is 0. And we then can fill individually each position using the variable name and its index. It's important to know that most programming languages actually utilize the 0 as the first index and go to the size of the array as 1, in this case to 14. But exists a few programming languages that utilize the 1 as the first position. So according to the programming language, we need to take care with the valid indexes. Another way for defining arrays is declaring one already defined array with informing the existing elements. Here is another case using the k brackets that we can separate the elements by comma, and in this case we are declaring one array with 5 elements from 19 to 6. So we have 5 elements defined from the type byte. So it's like we have 5 byte variables side by side, but all referenced by the same name. And why it's nice? It's nice because we then can run over all of them and process them. One array typically has one property that says what is its size. If you take the variable name, we can ask for that. Give me your length. How many elements do you have within? Then we can program based on the length of the array one loop that will iterate over each element. It's a very common feature when we are developing. So here we have one example of array that was non-initialized, and we have to initialize it element by element. And here we have one example of an array that was already initialized, but just initialized. It does not avoid us from update its values later. So we can instantiate already initialized, but then change any position after that. And here just examples accessing the element in certain index and displaying them. And here displaying the size of one specific array. We can execute that here just for take a look how that will behave. And here we have all array elements being displayed and displaying its index and its value and the length of the array. It's also valid to be retrieved So it's just important to take care to not access the arrays out of bounds. Otherwise, a problem will happen. In this my another array variable, we have 5 positions. So if I want to access one out of bounds index, for instance this 6 index, one error will be triggered. We have that here. Look at the message. Exception. It just executes the code until this line. Until this line. In this case, when it tries to, until this line. In this case, when it tries to execute this line, one exception was triggered, saying index 6 is out of the bounds for the one array of length 5. So it is one overview about how to use array variables.